Hello, everybody. So in this video, I'm going to be discussing project assignment number 5. So let me go ahead and screen share and we'll get started. Right. So this is the document that you'll do your work on, and then I'll go ahead and go through my sample here. All right, let me go ahead and stop my share and go over to the sample. All right, so the purpose of this project is you're going to be making a confidence interval for either your qualitative variable or your quantitative variable by hand and then with technology. So, as all like the objectives, we'll go through all of this. And as with all the projects, you get 2 attempts. The first attempt, if you get everything right, you get 100%. If not, you get a 50% until you make the changes I ask you to make, and then you should get 100%. If you want to see what constitutes the other grades, then you can look at the rubric and see that. You have a week to make the revisions with my feedback. All right, so you have 2 options here. You can either do your quantitative variable from assignment 4 or your qualitative variable from assignment number 2. So I showed both here, but you only need to do one. So I'm going to go through the quantitative one first. So my quantitative variable from assignment 4 was salary. If you're doing your quantitative variable, then you're going to be estimating a mean. And then you can copy and paste this formula into the document here. And then confidence level 95% is fine. This sample mean should come from your project number 4. You found the mean in project 4, so you just need to put that number in here. Now this here, so I'm looking to find this t value here in this formula. So first thing you need to do is find the degrees of freedom and the alpha over 2. So the alpha over 2 is 1 minus the confidence level divided by 2. So 1 minus 0.95 divided by 2 gives me 0.025. So that's going to be the upper tail in our GURU. And then the degrees of freedom is a sample size minus 1. My sample size was 397, which is 397 minus 1 is 396. And I'm going to show you real quick how to find that on our GURU also. So let me go ahead and pull up our GURU here. So to find the actual t value, so first of all, to find the sample size, you can just open your data set here, and then it says total rows here at the bottom, that's going to be your sample size. So if you're not sure what the sample size is, that's where you can find it. Now, to get the t value, you can go to probability simulation, probability, probability calculator, continuous. Probability values, since you're looking for a t value, you're going to change it to the student t distribution. My degrees of freedom were 396, and then the alpha over 2 goes in here as an upper tail. Check the graph box, and then hit the eyeball. So my t value is 1.966, and you can take a screenshot of this and put it into the document. You can see all that here. Now, the standard error, so this is the critical value, this is the standard error, then multiplied together is the margin of error. So you just need to calculate this using your numbers from project 4. So my standard deviation from project 4 is going to go here, and the sample size is going to go here. So my standard deviation from project 4 was 3289.04. divided by the square root of the sample size, which is 397. That gets me this number here. So I just put it into the Desmos calculator, and then I took a screenshot of that and put it into the document. So remember to get to the Desmos calculator. I'll show you real quick. Exactly what I did. So you can go to Applets, Desmos Scientific, and then you can type it all in here. So it was 30289.04 divided by the square root of 397. And that's the same thing that I got in my document. I just screenshotted it and put it into the document. So it's your standard deviation from project 4 divided by the square root of the sample size. And now, like I said, to get the margin of error, multiply your critical value and your standard error. So just multiply your previous two answers here. Make sure you don't round. So I use the whole number here. And when I multiply that out, I got this long number here. Once again, don't multiply it out. Oh, I'm sorry, don't round. Sorry. Do multiply it out, don't round. And then to get the confidence interval, you're going to take the point estimate, which is the sample mean, so the 113,706.5, subtract the margin of error for the left bound, and add the margin of error to the sample mean for the right bound. And that'll get me 110,718 and 116,695. And then let's go through how to actually do the confidence interval in our guru. So you're going to go to Analytics, Analysis, Mean Inference, One Population. Select your data set and your variable. And then 95% is fine. And then it's t-statistic because you don't know the population standard deviation. Hit the eyeball, and then you can screenshot this and put it into the document. You're going to use the lower CL and upper CL. And this should match. So it should match the one you did by hand. If it doesn't, you did something wrong. Which mine does indeed match, so I know that I did it right. And then make sure you always write your confidence interval in parentheses with a comma between the numbers. And then write your interpretation sentence. So for mine, so we are 95% confident that the population mean salary of college professors is between $110,718 and $116,695. So we are whatever percent confident that the population mean, whatever your data set is between the two numbers. Don't forget units. And then just write a little description about the confidence interval. So tell me about it, analyze it a little bit, and then who might be interested in it and how would they use it. So just talk about what you see. So mine, it's between 110,718 and 116,695. Seems a little high to me. So my confidence interval is higher than I would expect. So I wouldn't expect my average college professor salary to be this high. Maybe the school the data came from is a more prestigious school that pays its professors more. Without knowing the school, hard to say for sure. And then talk about who might be interested in it. So for me, researchers on college professors' salaries and college professors might be interested in it. So in the data system from 2008 to 2009, so this confidence interval could also be used for comparison purposes to today's data. So just talk about something like that, who they are, and how they could use it. All right, now remember you only have to pick one of these. So that was if you wanted to do your quantitative variable from assignment 4. If you want to do your qualitative variable from assignment 4, it'll be a little bit different. So my qualitative from assignment 2. So my qualitative variable from assignment 2 is sex. If you do your qualitative variable, you're going to be estimating a proportion. And in this situation, it's going to be a proportion of females. So you can either do, you need to tell me proportion of what for this. So sex is either male or female. So it can be a proportion of females or proportion of males. I chose females here. So you need to tell me proportion of what if you're doing if you're doing your qualitative variable. Copy the formula. This is the same. This came from my project 2 frequency table. So let me actually pull that up real quick to show you where I'm getting this from. Let me go ahead and share this. So I can see here, based on this, I have 39 females out of 397 total people. So remember, the sample proportion is the number of successes out of the number of trials. So basically, how many females out of the total? So 39 out of 397 would be the number of females out of the grand total. So that's where I got that fraction from. And then I just made a decimal here. We're going to be using the fraction throughout the project. The critical value, so with this formula, it's a z value, so it's a little bit different. But you're still going to calculate your alpha over 2. So 1 minus the confidence level divided by 2. So 1 minus 0.95 divided by 2 gets me 0.025. And now I'm going to go ahead and put it into our guru to get the z value. So you're going to go to the probability simulation, probability calculator, and continuous. Normal is fine. Keep this as is. It's going to be an upper tail of that alpha over 2 we calculated, which is 0.025. Hit check graph, hit the eyeball, and then you get 1.96, and you can screenshot this and put it into the document. So that's our critical value. So this is the critical value, this is the margin of error. I'm sorry, this is the critical value, this is the standard error. Then multiplied together is the margin of error. So my standard error is going to just be this part here. So I'm going to put it into the Desmos calculator and then take a screenshot and put it in here. So the p-hat was 39 over 397. Make sure you use the fraction. Sample size was 397. And then putting that all in the calculator, I got this here. So let me show you how I put that in here real quick. So to get to the calculator, it's applets, Desmos Scientific. And then let's make a square root, and then I'm going to make a fraction under the square root, and then 39 over 397 times 1 minus 39 over 397 all over 397, and that gives me the same number that I had in my document. And then you just need to screenshot it and put it into the document. And then to get the margin of error, multiply your two previous answers. So 1.96 times this long decimal here, don't round it. And that got me this number here. Once again, don't round it. And then to get the actual confidence interval, you take your point estimate, 39 over 397, subtract the margin of error for the left bound, add the margin of error for the right bound. That got me 0.069 and 0.128 for my two confidence interval bounds. And then I'm going to go through how to do it in our guru now. All right, so in our guru, I'm going to go under analytics, analysis, proportion inference, one population. select my data set, and then under the factor, you're going to select your variable, and then under your success here, you're going to select what you're doing the proportion of. So I'm doing the proportion of females, so I'm going to select female because that's what I consider to be a success. And then 95% is fine, and then check large sample Z. Hit the eyeball, and I get 0.069 and 0.128. So the same numbers that I got in my by hand version. You can screenshot that and put it into the document. And if you want to save any of these, then you can put like a title in this box and hit save as if you want to save any of them. And then write your interpretation sentence. So we are 95% confident population proportion of college professors who are female is between 0.069 and 0.128. So we are 95% confident that the population proportion, whatever, is between the two values of your confidence interval. And then, as with the previous part, talk about the confidence interval a little bit, what you think about it, and then who might be interested in it and how would they use it. So my confidence interval shows there's not many female college professors, which is pretty interesting. It doesn't make a lot of sense to me. So maybe the school that it was collected from attracts predominantly male professors. Hard to say for sure, but it's definitely interesting. And then who might use it? This is the same blurb that I had as above, so I'm not going to read it again. Just talk about who might be interested in it, and then how they might use it, either for comparison purposes if it's from the past, or if it's current, talk about how you can still just talk about how they can make use of this information. All right, and that is it. So that is, remember, you only do one of the two. So you can either do your qualitative variable from assignment 2 and do a proportion, or your quantitative variable from assignment 4 and do a mean. We only do one of them, but I have both there for sample purposes. And so that is it. So that is project assignment 5. If you have any questions, please feel free to reach out.